Here, whoops. We are doing 2.6 special functions. And in this section, we're going to learn to graph piecewise functions and identify their domain and range. And we're going to write the piecewise functions given the graphs. So let's start from the beginning. So let's start with our vocabulary. So what is a piecewise defined function? Basically, it's a function that's written using two or more expressions. Okay, so let's go straight into the example and let's look at example 1. So this is a piecewise function, and students often get this really confused and they struggle with this. Okay, so let's break this down. So I'm going to rewrite this, and it says f of x equals, it looks like it's really complicated, but it really isn't if you understand what the format is. Okay, so let me write it out here. -1. And they want us to identify the domain and range. So remember, what is f of x? It's a fancy word for writing y. Okay, so I can rewrite this. Okay, it's less than -1, and if x is greater than -1. Okay, so here, these ifs, they belong to each one of these lines. We have 2 rows here. So this is actually defining the domain. Okay, we're putting restrictions on the domain, and this is what we're saying they are. And if we go back and look at this graph here, we can say, so we said it's y equals, so basically I have how many rows? I have 2, so I have 2 different equations. So I can break this down and say y equals x minus 2 if we restrict the domain to x less than -1. I'm going to put in parentheses. And then we can say y equals x plus 3 if we restrict the domain to x greater than or equal to -1. So what does that look like? So let's look at what a graph is going to look like. So if my x and y axis, so you guys know how to graph that, right? It's in slope-intercept form. So we're not going to spend time learning how to graph. If you need help, check with me during class and I'll explain this. So I'm going to graph this. So here's my -2. I have a positive slope. It's going to do this and this and this. Now, it says restrict my domain to the x value. So it's the x value. So my domain is x less than or equal to -1. Where is -1? It's right here. So I'm going to come down to that graph. Because it's less than, it's going to be an open circle. Okay, my graph would do this. Okay, but at -1, x is going to be 1 to -3, and I'm going to have a circle, which means that I have to erase everything to the right because I don't want that to be part of my domain. I'm restricting my domain to be from here this way. So I'm going to go down to the graph circle and just make the graph to the left. Everything to the right gets erased. Now this one is going to be here. All right. And I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. And it says I want to restrict my domain to x greater than or equal to -1. So I can go down 1, over 1. So it's going to be right here. And it's going to be inclusive, so I'm going to make a dotted line. And there is my graph. All right, so let's erase what's not the graph so we're not confused. Okay, so that is how you would graph that. It's not hard, it's not confusing. You just have to break it down. F of x is a fancy word for y, and we're just saying we've got 2 equations, y equals x minus 2 and y equals x plus 3, but we're restricting it to the domains of x less than -1. So you go to -1 and say, I'm only going to take the left side, everything to the right. It's not inclusive because it's just a less than. And then the second graph is x greater than or equal to, so -1 is right here, and it's inclusive, so it's a filled in dot, and it goes to the right. All right, pause it, do guided practice 1, and then we'll resume. Okay, so we're back. Now we're going to talk about, we're going to do example 2. Erase this and let's scroll down to example 2. Example 2, now they're going to give us the graph and they want us to write the piecewise defined function shown in the graph. So if we look at this, we've got one piece here, two piece, three. So we have 3 different lines. So we know we're going to start with f of x equals, okay, so I'm going to have 3, just for purposes, I'm going to put a dot so we know that we represent 3 different equations. All right, so let's look at the first one again. So in order to write an equation, it has to be in this format for a piecewise, has to be in slope-intercept form. So we need an m and a b. So if we look at the graph, you can see where's the y-intercept? 1, 2, 3, 0, 3. So my b is going to be, for that particular first one, it's going to be, so let's do it here, 3. And my m, my slope, well, I can look at it and go, well, it goes up 1, up 2, over 1. So rises 2 over 1 is positive, so my slope is 2 over 1, or simply 2. So my equation is y equals 2x plus 3. And I don't need to put the y because that's what f of x is. So I'm just going to put, let's do it, 2x plus 3. Okay, now let's look at the restrictions. So that's the equation. It stops at what? Right here. That x value, that coordinate is 1 comma whatever y is. I don't care about the x, I just care about the y's because we're restricting the domain, which are x. So that's 1, and the graph goes to the left, so we're going to say x is less than 1 because it's an open circle. So my restriction is, we'll put our restriction in. Let's make it a pretty blue. Okay? If x is less than 1. Okay? So let's go to the second equation. So we have here 2 coordinates. 1, so we can find the slope. So it goes down 1 to the right 1. So our slope on that one is -1 over 1, or simply -1. What would our y-intercept be? Well, we can figure that out. We know our slope is 1, 1, up 1, over 1. Oh, there puts me on the y-intercept. Whoops. Up 1, over 1, which would be at 2. 0, comma 2. So my b is 2. My equation is y equals -x plus 2. So I'm just going to put -x plus 2. And what is my restriction? Well, it's just from 1 and 2. So if we had a number line, that restriction is from here to here. So we're saying if x is greater than or equal to 1, less than or equal to 2. That is my restriction. Okay, so let's look at the next one. What's the next line? Oops. It's a horizontal line at what? 1, 2, 3. So that equation is just y equals 3. But we see it goes from 3, or 1, 2, the x coordinate 2, and to the right. So we're saying that restriction is going to be if x is greater than 2, and our equation is just going to simply be y equals 3. So we just put, remember, we write the equation out so you don't get confused of the line, and then we're going to drop the y in the equal, and we're only going to put to the right, which is 3. There's your piecewise function from this graph. So try guided practice 2A and 2B and pause your video. All right, we're back and we're looking at number 5. So we're going to go back to our vocabulary and we have to know what is a piecewise linear function and a step function. Okay, so piecewise linear function just contains a single expression. All right, so an example of one is called a step function. It's a common piecewise linear function which consists of line segments. And one type of step function is the greatest integer function. And it's written in the form of f of x equals, and it's basically 2 brackets, not 1. So this symbol, how this is read right here, it says it's read what is the greatest, what is the integer that's less than or equal to x? For example, if I said evaluate 3.25, okay, what's the integer that's less than or equal to this? 3. What about, this is one that students always mess up, negative 4.6. This is going to be negative 5, because think about a number line. You have negative 5, negative 4, and right here is negative 4.6. So I want an integer that's less than or equal to. From here to here, what's the first integer? It's not negative 4, it's negative 5. That's less than or equal to negative 4.6. Okay, so let's look at what a greatest integer function graph looks like. So this is the greatest integer, and this is the parent function. And if you notice, it starts with a closed dot on the left and an open on the right. And then so think of these as steps. All right, so let's look at the first real world example using this information. It says an automotive repair center charges $50 for any part of the first hour of labor and $35 for any part of each additional hour. So the first thing we need to do is we need to draw a table that represents this. So we say x and f of x. So we said when x is greater than 0 but less than or equal to 1, you're going to get charged $50. Now, why is this not a less than or equal to sign? Why is it just a less than sign? Well, if we don't have any work done, there's no charge. So if we have 0 hours of labor, then it's 0. So it has to be greater to have any work done. All right. Then we said the next hour. So we're saying when when x is greater than 1 but less than or equal to 2, it's going to be $85. And when 2 is less than x less than or equal to 3, we have $120. And then when we have 3 hours is less than x less than or equal to 4, it's going to be $155. And when 4 is less than x less than or equal to 5, it's $190. So how do we graph this? Well, let's look. So the range is x is from 0 to 1, so we have up to 5. So it's not included, and then to 1, oops, sorry, 20, 40, 60, 80, 100, 120. So I'm going to make these 20, 40, 60, 80, 100, 120, 40, 160, 180, and 200. So you could have done it probably by 40s. All right, so from 0 to 1, f of x or y is going to be 50. So this is 60, so 50 is here. So we're going to do a circle to including 1. All right, so now we're going to go from 1 to 2, so it's going to be $85, which is somewhere right here. Open circle, close circle. And then from 1, 2, 3, 4, 5. So that's a range of 1 to 2. Now 2 to 3, at 2 is going to be $120. Okay, so open circle to 3, close. And then at 3 to 4 hours, it's $155. Again, open, close. And then from 4 to 5 is $190. So we're saying y is between 4 and 5. So again, open because it's not inclusive, and to a closed circle y. All right, pause this. Try guided practice 3 and then come back. All right, we're back in our very last vocabulary of this section of type function that we're learning. Is called an absolute value function. An absolute value function is just another type of piecewise. It's a function that contains an algebraic expression within absolute value symbols. So what does that mean? You're like, that makes no sense to me. So let's look at this. Let's look at the graph. So f of x equals the absolute value x is the parent function of an absolute value. This is what the graph looks like, and technically it's a piecewise. So you have a positive slope linear function here, you have a dot at 0, and then you have a negative linear. So you have 3 parts, 2 lines and a point. So when you say this, we break it down to say f of x equal x. It starts here and goes up. It's just graphing y equals x. But we said greater than 0. So it'd be a circle at the vertex, at the origin. And then we said if y equals 0, which would be a line this way, but only when x is 0. So it would just be a point, not the entire graph. Everything else would be erased. And then we have this right here, which is y equals negative x, and it's less than 0, and it's going to go this way. Okay, so the domain is going to be all real numbers. The range is going to be all non-negative real numbers, or simply y greater than or equal to 0. And the intercepts are going to be at x equals 0 and y equals 0. They're at the origin. Both intercepts are at the origin. And it's not defined as a parent function when y is less than 0, because it goes with the range. So let's look at an example. They want us to graph this function and identify the domain and range. The next section, we're going to learn transformations. They'll make this much easier. But for now, in order to graph this, we have to make a table. So we're going to create a table, x and y, or f of x. So we're going to just pick some points. -3, -2, -1, 0, 1, 2, 3. And our function was f of x, excuse me, absolute 2x. I'll do this first one. So this is why we did all those exercises. And this becomes absolute value -6, or 6 minus 4, or simply 2. I'm not good for time purposes. I'm just going to give you what these values are. You can put them in your calculators, or you can do the f of each one. So you can do f of -2, f of -1, so on and so on. You're getting the y. So now we have coordinates. Can we graph these coordinates? Yes. Let me actually move this over here where I have more space. So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. So now it's just a matter of graphing our points, -2, whoops, -3, 2, sorry, graphed that wrong. Oops, I still graphed that wrong. Let me erase this. Okay, so -2, 0, -1, -2, 0, -4, 1, 1, -2, 2, 0, 3, 2. So my graph, if I connect the dots and if I had a nice pretty graph, this is what it would look like. Pretty simple. Make sure you put your arrows because these are 2 lines that keep going. All right. Stop the videos. I want you to attempt guided practice 4A and 4B, and we'll see you in class.